Hello and welcome to another DazToHue tutorial video. In this video we'll be taking a high level look at the new animation retargeting nodes that came with release 1.2. Now before we get started, just a couple of things to mention. The first is that these nodes are still in what I would call an experimental state. They are early on in development and there are a few things I'd like to improve on them if I can. Secondly, these animation nodes may well become redundant with future versions of Unreal Engine. It looks like Unreal Engine 5.4 is coming with some fancy new animation retargeting capabilities built in. So whether or not these animation retargeting nodes remain relevant in future is yet to be seen. And lastly, before we get stuck in, I won't be going into great detail in how the full body IK solving works in Houdini. You'll find information about that online, both on YouTube and in the side effects documentation. So I'd encourage you to look that up so you'd have a better understanding of how IK retargeting works in Houdini. In particular, some of these sort of fine-tuning adjustments you can make to get a better solve. So to get started, let's jump back over to DazToHue just for a minute and talk about one thing we need to do if we are wanting to retarget animations out of DazToHue. At the very least, you're going to want to load the retargeting poses for your particular base figure type. So in this case I'm working with Victoria 8.1. So on frame 0 you would want to load the retargeting poses, which are here. So hold down Control, double click that, turn off limits and accept. The reason we need these is because the IK solver needs a reference frame both on the source and target skeletons, and that frame needs to match in pose, very similar to how it's done in Unreal Engine. And depending on the situation, it will either use frame 0, which is the Daz default rest pose, or it will use frame 2, which is a T pose. And so after frame 2, so on frame 3, I would then load my animation. If I just quickly drop this walk forward animation onto it. So again, I'm starting on frame 3. Gonna load walk forward, say yes, it will extend the timeline. So we now have our animation, but importantly, our first 3 frames are still those reference poses, those retargeting poses. So with that done, I can now export this as an FBX animation. So if I go to File, Send to Maya, change asset type to animation. We don't need to worry about subdivisions or anything. We only care about the animation. The geometry itself doesn't matter. I'll hit accept. So now that that's done, we can close Daz. Now I'm just going to locate that animation and I'll rename it. So I'll call it V81 walk forward. I find it's useful to put the figure type, certainly the base figure type, in the animation name just so I know where it came from. And I have this animations folder where I've just gathered some different animations we can work with. I'm just going to copy it into there. So now let's jump back to Houdini. So there's 2 different ways to add the animation retargeting nodes. The easiest is just to use the shelf tools up here. Alternatively, you can right click in the network editor, go to DazToHue animation, and you'll find them in there as well. So let's start with the Daz retargeting. So I'm just going to click the Daz retargeting button up on the shelf tool. By default, that will place it in the center of our network editor. So you can just move it to wherever you want it. I'm going to select the node and set its display flag. You'll see we get an error. That's because we need to tell it where to take the DazToHue character from. So to do that, we just need to drag one of these nodes into this import from field. You want to make sure you're using a node that's either from the skeleton down. You don't want to use the import or skin nodes because the skeleton hasn't been corrected at this point. Typically I just use the skeleton. So I'm going to click and drag that into this import from field. You'll see we now get our character back, and by default it'll just show the standard range of motion animation. The next thing we need to do is give the node some animations we want to retarget from. You can either add them manually just by selecting an animation file and giving it a name, but easier still, you can just click the Select FBX Files button. I'll come to where I've saved some Daz animations for us to test. I can shift click and select multiple animations and then just accept, and that will auto populate the list for us. At the top of the node there's a preview animation drop down, so we can now select one of these animations. So I'm going to select the animation we just exported out of Daz, which is this V8.1 walk forward. Now, if I scrub the timeline, we should have our animation being retargeted onto this character. So the Daz retargeting animation node has two different transfer methods. The first is this direct transfer, and as this note is telling us, this will only work well if the animation was exported with the exact same character that we are retargeting onto. So in this case, it was exported with this character, this Victoria 8.1 character. And that means the direct transfer method will work perfectly. And by perfectly, I mean it's the exact one-to-one transfer of the animation. There's no IK solving going on, so it is 100% accurate. But like I said, the limitation is that the source animation must be generated with the exact same character. If there's any difference in skeletal structure or size or things like that, it's not going to work that well. So to demonstrate that, let's change the animation to one that was generated with a Genesis 3 character. Now if I scrub through the timeline, you'll see things look wrong. And like I mentioned, that's because the direct transfer method doesn't work well when there are significant differences between the source and target skeletons, as is the case here. We're going from Genesis 3 to Genesis 8.1. So in those scenarios, it's best to use the IK solver transfer method. So if we come up to this transfer method drop down and change it from direct to IK solver, you can see now we're not getting any animation transfer. And that's because we need to load the bone mappings that map between Genesis 3 to, in this case, Genesis 8.1. So to do that, we need to tell the node what the source skeleton is. So in this case, we know it's a Genesis 3 skeleton. Then I need to click this Load Default Mappings button. And as I say, internally that will load the mappings between Genesis 3 and Genesis 8.1 for us. If I click that, it's just going to warn you that it'll override any custom mappings you may have done inside the node. We'll get to that in a little bit. For now, I'm just going to say OK. And there you can see we are getting animation retargeted from a Genesis 3 source to a Genesis 8.1 target. So they're the two different transfer methods that the Daz animation retargeting node provides. The Rokoko and Mixamo nodes only have the IK solver method. You can't do a direct transfer from them. We'll look at those in a little bit. The Daz animation retargeting node is the more complex of the three because it has to deal with various different source skeletons, whereas Rokoko and Mixamo only have the one skeleton as a source. A couple of other things to demonstrate. Under Visualize, you can change to Ghosted mode so you can see the underlying skeleton. You can include the source avatar in the preview window here, so we now see the source on the right and the target on the left. Let's just preview one more animation. So let's change it to the Genesis 9 run animation. We can see it's not working well at the moment. That's because we need to again load the mappings from Genesis 9 onto Genesis 8.1 in this case. So if I change the source skeleton type to Genesis 9, load the default mappings again, hit OK. See, we're now getting proper retargeting. What this effectively means is that for each Daz animation retargeting node, you can only retarget from the same source skeleton. So for example, in this case, I can only retarget from Genesis 9 source animations. So I would delete all the Genesis 3 and Genesis 8 animations from this node. And I would create a new node if I wanted to retarget from Genesis 3 or Genesis 8. So I'm going to do that. I'm going to delete this Genesis 3 animation, this Genesis 8.1, this Genesis 8.1, and this last Genesis 8. So we're now just left with this single Genesis 9 animation. When you delete them, you might have to come up and just change the preview again. So we now have a single Genesis 9 animation being retargeted onto this Genesis 8.1 character. Another thing to point out is that we have this force motion option. You'll see, looking at our target skeleton here, that the root bone is being left at the world origin. If we wanted to force this to be a root motion animation, we can change this force motion option to force root motion. That will make sure that the root bone and all the various helper bones follow along with the movement of the character. Alternatively, if we wanted to force it to be an in-place animation, we can do that by selecting Force in Place. Now the character's forward motion has been extracted out and it's remaining at the world origin. So that's briefly it for the Daz animation retargeting node. Now let's just take a quick look at the Rokoko and Mixamo nodes. So I'm just going to add both of those by clicking on the shelf tools. Again, they get placed at the center of the network graph, so we can just move them to where we want them. I'll start with the Rokoko node. I'll set its display flag. Same as before, we need to tell it where to take the DazToHue character from. So I'm just going to click and drag the skeleton node into this import from field. And again, same as before, I'm going to select some Rokoko animations. Now, just as we did before, we can come up to preview animation and select one of them. Now, unlike the Daz node, we don't have the transfer method options. As I said before, it's always using the IK solver under the hood. So we don't need to do anything else. We can now just preview the animation. The Rokoko animation retargeting node will handle facial animation as well. So if the animation has facial animation curves in it, they will get transferred and exported out as well. And again, we can include the source avatar so we can see on the right our original Rokoko motion capture. On the left being retargeted onto our character. Let's quickly have a look at a Mixamo animation as well. So we'll do the same again. We'll drag our skeleton to this import from field. We'll select some Mixamo animations. Again, we can preview it. Here we have our Mixamo animation being retargeted onto our DazToHue character. Again, we can include the source. We also have this ghosted view. All the same options that we had before on the Daz animation retargeting node. We can force it to be root motion. So a couple of things to point out that still need a bit of improvement, which I haven't solved yet. If we have a look at the Rokoko animation, scrub up to a particular frame. A few things I haven't quite solved yet. One is how to handle twist rotations. So the Daz skeletons have a twist bone, whereas the Rokoko and Mixamo skeletons don't. As such, the Rokoko animations seem to do a lot of twisting around the hands, more than should anatomically be possible, I would say. They also seem to do, in some cases, some twisting at the elbow, which shouldn't be possible. So sometime in the future, I'm going to try and figure out how to transfer the twisting that's happening, or at least the bulk of the twisting that's happening at the wrist and the elbows, how to better distribute that onto the twist bones that Daz provides. It's something I haven't quite figured out yet. Another thing to point out that I noticed is the fingers on Rokoko animations, and to a lesser degree Mixamo animations, aren't great. If we have a look at our pinky finger here, it looks very much broken. It shouldn't be able to bend to the side at this joint like it is here. The odd thing is that it looks that way even on the source animation. We have this unnatural bend, like this pinky finger's being broken. It is possible to correct that to some degree, and we'll briefly talk about that in a minute. But just something to be aware of, that the target animation is only as good as the source, but you can, using some Houdini tools, try and improve the source before retargeting as well. Another thing I need to point out, because this will confuse some people, and I appreciate it is confusing, Currently our target character, our DazToHue character, is using the native DazToHue skeleton. So we are seeing the actual character on the animation previews. However, if I change it over to use the UE5 mannequin skeleton, you'll see now we are actually seeing the Unreal Engine 5 mannequin in the animation previews. This is because that is exactly what's happening under the hood. The way that DazToHue goes about generating a UE5 mannequin compatible skeleton basically means that when you are retargeting animations from either Daz, Rokoko or Mixamo onto a UE5 compatible DazToHue figure, you actually want to retarget the animations onto the unchanged UE5 mannequin skeleton. We don't want to retarget onto the modified DazToHue compatible skeleton. Like I say, that's just due to the way the current UE5 compatibility is working. Making Daz skeletons compatible with Unreal Engine 5's mannequin skeleton is fucking hard. And it's an area that there isn't a lot of documentation or sort of knowledge sharing going on around. It's a whole lot of trial and error trying to figure out the best way of doing it. It is possible to brute force the Daz skeleton to be exactly the same as the Unreal Engine mannequin skeleton, but that comes with several drawbacks, so that's not what I'm currently doing. Instead, I'm doing a bit of a mix of brute force altering the Daz skeleton, but still leaving some of the original Daz skeleton orientations and bone positions in place. I've just found after a lot of trial and error that that's giving me the best results. But it's also an area I will continue to explore. And it's another area of these animation retargeting nodes I'll plan to revisit in the future, provided they remain relevant and don't get superseded by anything Epic's doing in Unreal Engine 5.4 onwards. Ideally, it would be nice to see our original DazToHue character here instead of the mannequin, but at the moment I haven't quite solved the best way of doing that. So just wanted to point that out because no doubt that will confuse some people. For now, I'm going to change back to using the DazToHue native skeleton for this demo. Unlike every other node in the DazToHue tools, these animation retargeting nodes are deliberately unlocked. This means you are not only allowed to dive into them, but you are encouraged to dive into them in order to make sort of fine-tuning adjustments to the retargeting. So to do that, if we right-click on one of these nodes, in this case the Rokoko node, and select Allow Editing of Content, we can now dive into the network graph inside. Now I've tried to color code things, so if you stay in the green sections and the green nodes of the green sections, you shouldn't break anything really. And this is the same for all three nodes. So in this green animation retargeting section, you'll see two green nodes. The first of these green nodes is the mocap cleansing subnetwork. At the moment it's completely empty, but if you needed to do any pre-cleansing of the motion capture data that's coming in, this would be the place to do it. So for example, if you had particularly noisy motion capture data, you might want to drop down something like the smooth motion node, plug that in, and you can adjust various settings to smooth out some of the noise or jitteriness on that mocap data. The next of the green nodes is the animation retargeting subnetwork. This is where all of the actual IK solving happens. So if we dive into there, again, if you stick within the green section, you should be right. I've added some comments just to explain what each of the nodes are doing. Just to quickly run through them, the map IK bone node is basically doing just that. It's mapping the bones between the source and target skeletons. It's only mapping the bones we need. We don't need them all, and the IK solver works better with a sparser list of bone mappings. So for example, we aren't mapping the finger and toe bones. We're just mapping the core bones that make up the animation, so the legs, arms, and spine primarily. And if we hover over the viewport and hit enter, we can actually see those mappings in the viewport. So the blue skeleton is the target, it's our DazToHue character, and the green skeleton is the source, in this case our Rokoko animation. You can add additional bone mappings if you want, just by dragging from one bone to the other. But in this case I don't want to map any more bones, so I'm just going to hit escape to come back out of that. The next of the green nodes is the tweak pose offsets node. So if we have a look at that, that is used to fine tune the initial reference frame on both the source and target skeletons. So again, if I have it selected and hit enter on the viewport, You'll see both the source and target skeletons overlaid. The blue again is our target character and the green is the Rokoko animation. And you can use this to fine tune the orientation of the bones as they are being solved. So to just demonstrate that, if I come back out of this node, and I'm just going to change the animation we're previewing in this case. Pick a frame that we want to look at. Now, if I pin the viewport by clicking this little pin in the top right, we'll now stay in this view as we dive into the network. Now what I can do, you'll see on the tweak pose node, we have our upper left and upper right arm already added. And you can add more if you need to tweak it. And I find it easier to work with this pin view so that I can see the end result as I'm adjusting things. And what we can do is adjust the initial rest, or that initial reference frame, in this case of the target skeleton, just to fine tune the orientations of the joints that are being solved. So for example, for our right arm, I can come to the upper arm right here and just change the Y rotation a little bit. We can see that changing on the left in the viewport. And so this is how you can, as I say, make fine tunings to the retargeting. But you want to be careful. You want to scrub through the animation and make sure we're now not getting any clipping going on other frames. So that's too much. So we might just bring that back again just to avoid that clipping. So that's an example of how to use the tweak pose offset node. Going to unpin the viewport, hit escape to get out of that. Next is the IK solve, which is doing the actual solving between the source and target skeletons. I'm not going to spend too much time on this. You can look up the Houdini documentation for these nodes. It's called the full body IK node. The one thing I do want to point out on this node is this configure section down the bottom. It's quite useful. You can use it to, I guess, give a higher priority to certain bones during the IK solving process. So for example, if you find your feet aren't quite sticking or they're jittering around, as I've done here, you can add the foot bones to a configuration and you can increase its priority. And that means the IK solver will do it more work to try and keep the foot bones in place at the expense of perhaps some other areas of the skeleton. As I say, the biggest use I've found for it is to do with feet and keeping those, for example, sitting on the ground properly. And the next two nodes are all to do with fingers and toes. So as I said before, the IK solver works best with a sparse mapping between the source and target skeletons. So we don't typically use it to solve the finger and toe rotations. Instead, we use a different method called FK transfer. So the map FK bones node is doing exactly what the map IK bones node did, but it's doing it for fingers, and if the source animation had them, it's doing it for the toes as well. Rokoko doesn't have toe bones, so in this case it's only mapping the fingers. And then the last node, this FK transfer node, is doing the actual transfer of the finger or toe rotations onto the target skeleton. So as I said at the beginning of this tutorial, I don't want to go into great details about how Houdini's animation retargeting works. You'll find other tutorials online with basically this exact same setup. You'll also find help in the Houdini documentation. So I encourage you to read up on that to get the best IK retargeting solve that you can. You will likely need to do a little bit of fine tuning on some of these nodes, as I've briefly demonstrated, in order to get the best result. That's exactly why I've left these nodes unlocked and encourage you to delve into them and have a bit of a play around. So the next thing to talk about would be how we go about exporting these animations. You'll notice that none of the animation retargeting nodes have any sort of export options. And that's because exporting is still handled by the DazToHue export node itself. So if we go to that, first thing we need to do is tick this export retargeted animations option, and then you'll see it has an import from field, just as the animation retargeting nodes had as well. So similarly to how we dragged the skeleton node into this import from field, on the export node we can drag one of these animation retargeting nodes into this import from field. Now we just need to click this export with selected options button, or we can click export retargeted animations only. In this case I'll do selected options. You'll see it will export not only our character, but also in this case any animations that were on this Daz animation retargeting node. In this case it's exporting our run G9 animation. So if I quickly look at the export directory, you'll see we have an animations folder with our run G9 animation in it. So what if we want to export all the animations at once from all the animation retargeting nodes we have set up? In that case, what we need to do is merge them. So if I right click and type in merge, I'm going to select this merge node. Then I'm just going to merge all of our animation retargeting nodes together like this. Then if I come back to our export node, and this time I'm going to drag the merge node into this import from field. Now if I do the same again, this time I'll just export retargeted animations only though, and it will now export all of the animations from all of the retargeting nodes that we have in our scene. So that's now finished exporting. We can see that it's exported 6 animations in nearly 4.5 minutes. Exporting is a little slow at the moment. It is another area I'd like to improve in future releases. I think I will be able to get some performance improvements by clever caching strategies, but I haven't gotten to that yet. So just to finish off, I've imported that Victoria 8.1 test character into Unreal Engine, along with all the animations we exported out of Houdini. So we can just preview them now, starting with this butterfly twirl, which was a Mixamo animation. We can see that playing on our character. We also have the idol with face, which was a Rokoko motion capture animation. Now I haven't set up the animation blueprints and everything to get facial animations working on this test character, but this Rokoko animation does have facial capture and it does work. I've tested it before. We have our G9 run animation. So again, this was from a Genesis 9 character onto this Genesis 8.1. And we did leave force in place enabled, so hence it's staying in place. Just a couple of others. Again, these are Mixamo animations. So that's basically it for, I guess, the animation retargeting nodes that come with DazToHue 1.2. I hope you found this video useful, and I'll see you in the next one. Bye.